Good morning, my YouTube viewers. In this particular video, what we're going to do is an A/B test concerning sign-up rates for an application. And the specific question that we're going to answer is, does moving the sign-up button to a more prominent position on the app's home screen improve the user sign-up? And what we're going to do is we're going to write a program in Python to answer this question. And before we write the program in Python, what we need to do is we need to import some libraries, because Python needs libraries in order to execute the program. So we're going to import NumPy SNP, which is a numeric library that also creates NumPy arrays. We're going to import matplotlib.pyplot as PLT, which is a visualization library. And from scipy.stats, we're going to import chi-square contingency. So scipy is Python's scientific library, and stats is a statistical module within scipy, and chi-contingency is the test that we're going to be performing. So after we have imported our libraries, what we want to do is we want to simulate the sign-up data for A/B testing. And the first thing we do in that regard is we're going to set the seed. And the reason why you need to set the seed is so every time you run the program, the variables will initialize to the same values. And so that helps the program to run the same way every time you run it. So you do that by typing np.random.seed brackets 42. And so the total users equals 1,000. So group A is the original sign-up button position, and that is the control group. So group A users equals total users floor 2. So that's going to be 500. And group A signups equals np.random.binomial brackets group A users, comma 0.20. So you're going to have a 20% conversion rate for group A. And the binomial distribution has one of two responses. It can be 0 or 1, on or off, true or false, yes or no. But it's one of two answers in the binomial distribution. So now what we do is we're going to set up group B, which is the prominent sign-up button position, which is your variant group. So group B users equals total users floor 2, which is 500. And group B signups equals np.random.binomial brackets group B users, comma 0.30. And so that's a 30% conversion rate for group A. So we've already set it up so group A is a 20% conversion rate and group B is a 30% conversion rate. Group A is your control group and group B is your variant group. So we're going to create a contingency table for the chi-square test. So data equals NP array, and then it's going to be the first row is group A signups, comma group A users minus group A signups. And the second row is group B signups, comma group B users minus group B signups. Okay, so now what we're going to do is we're going to perform our chi-square test. So chi-square, comma P, comma underscore equals chi-square contingency data. And then we're going to print the results. So you're going to print group A/B test results. You're going to print group A sign-up rate, that's the original or the control group. Group B sign-up rate, that's the prominent or variant group. Chi-square statistic, and your p-value. So we come over here to the bottom of the cell. So A/B test results is group A sign-up rate is 19.2%, and we set it up for 20%. And group B sign-up rate is 30.40%, and we set it up for 30%. chi-square statistic is 16.22, and the p-value is 0. And so basically what happens is your p-value is your probability. So if your p-value is less than 0.05, then you have to reject the null hypothesis. And the null hypothesis would be there is no significant difference between the sign-up rates, and the alternate hypothesis would be there is a significant difference between the sign-up rates. And so it says the result is the difference in sign-up rates is statistically different. So that means that you reject the null hypothesis and you accept the alternate hypothesis. So we go back and we check the p-value, which is what I just covered. If the p is less than 0.05, print result, the difference in sign-up rates is statistically significant, which it is. Now we're going to plot the results. Labels equals sign up, comma, did not sign up. Group A data equals Group A signups, comma, Group A users minus Group A signups. Group B data equals Group B signups, comma, Group B users minus Group B signups. X equals np.arrange, and it's len labels. So that's going to be 2 because you've got 2 labels being sign up and did not sign up. And width equals 0.35. So now we're going to create a bar chart. plt.figure brackets fig size equals 6,4. And so plt.bar brackets x minus width divided by 2, comma, Group A data, comma, width, comma, label equals Group A original, comma, color equals blue, comma, alpha equals 0.7. And plt.bar brackets x plus width divided by 2, comma, Group B data, comma, width, comma, label equals Group B prominent, color equals orange, alpha equals 0.7. So now we're going to add labels and annotations. The title is Sign Up Rates, Original versus Prominent Button Position. X label is Outcome. Y label is Number of Users. X ticks is X, comma, labels. And legend, you get a legend. And the grid is axis equals Y, comma, line style equals dash, comma, alpha equals 0.7. And now we're going to type some code in there so the numbers will actually be printed above the bars. So we have print type layout and print.show. And so this is the chart that we created. So Group A is the original or control group, and that's blue. Group B is the prominent or variant group, and that's orange. So 96 people signed up for Group A and 404 people didn't sign up for Group A, totaling 500. And 152 people signed up for Group A and Group B, and 348 people didn't sign up for Group B. So that's 152. So what the decision would be made would be that they would select the prominent position, because the prominent position would have more people sign up than not sign up. But, we already set up the synthetic data for that purpose. So that concludes this video. In the next video, I will be talking about another AP test, and I hope that you decide to watch it.